Hi, I'm Michael. I'm one of the bioengineers at 21D, and this is the Metal Milling Centre. This is the second building we've had. We've had it for about 5 months or so. We're mainly doing the metal milling so far in here, so we've got metal milling machines in the other room. It's slowly starting to get better and better, more consistent results. Essentially, we're just doing the titanium bars for the final LTPs, the long-term prosthesis. They're made from titanium, and then obviously we have the PMMA cemented on top of those. The reason we use titanium is just because it's biocompatible. The patient could be allergic to other materials, so titanium is quite a safe material to use in the mouth. It's also strong and lightweight, and it doesn't tarnish. All of the designs are done by our design team. They get sent over to us, and then the STL files are ready for me on the computer already. I load them into the CAM software the same way you would do with the PMMA. You orientate them on the disc. So we have the shape of the disc here, we have the bars, and we just position them as efficiently as possible. So you can see the STL files on the CAM software, so if there's any imperfections, which I have noticed before, it's just a quick message to the design teams like, hey, can you look at this? And they get back to you within 5 to 10 minutes and just adjust it quickly and fix it. 99% of the jobs are spot on. Everybody knows what they're doing, everybody's professional. The standard ones take about between 4 and 5 hours per bar. The ones that have the Terry guides take a bit longer, and you can fit 3 or 4 on a disc. For example, if you fit 3 on a disc, which is comfortable, it would take about 13, 14 hours. So it's a machine that we're running overnight, and in the morning we come in with 3 bars, 4 bars. The disc needs to be constantly cooled with liquid, but you can set the tool life, how many minutes the burr lasts. So we've adjusted that, we've adjusted the coolant a little bit, and we're fine tuning it. You can't go too fast because obviously the burrs snap, so the machine needs to go at a certain speed to mill precisely, and obviously it's a hard material, so there are limitations. These bars have already been finished. They took about 6 or 7 hours to mill. What happens is the machine comes from this side of the disc and mills this side, everything on this side, and it flips over and it mills everything from this side. This one's already been milled, it's been removed already and finished. The fitting surface of the bar, the underside of the bar, we polish to a high luster shine. The reason we polish the fitting surface is so that most of the plaque doesn't stick to it. Obviously, if you have a shiny surface, less bacteria and plaque is going to build up. And the reason we rough the other side of the bar, where the PMMA would sit, is so that the cement will bond to it. So we sandblast the bar and we put a metal primer on it, and that just helps us to achieve a nice cemented adhesive area. Any issues that we have, remakes or something like that, it's usually the PMMA that we're replacing, but the bar can be reused as long as there's nothing wrong with it. I've seen some patients come in and they've had their bar for 15 years or longer, so if they're looked after and if there's not any issues, then they should last a lifetime.